In this video, we'll look at simplifying complex algebraic fractions. Complex algebraic fraction has a fraction top and bottom. So there's two ways to do this, and we'll look at both ways. If we take just the top part of this fraction, 1 minus 9 over x squared, if we imagine that the 1 is a fraction as well, 1 over 1, we can simplify the bottom part to just be 1 times x squared, and then we cross multiply x squared by 1 and 9 by 1. And then we do the same to the bottom. We have a 2 over 1, so in the bottom part of the bottom we're going to have an x, and on top we're going to have 2 times x plus 6 times 1. Now what we do is we bring our fraction up, turn it upside down and multiply, back to primary school rules. So we have x over 2x plus 6. So bringing this whole line down, what can we do with it? We have the difference of two squares, x squared minus 9, so we're going to get x plus 3 by x minus 3, and we have that x there. And on the bottom we have 2x plus 6 times x squared. Now you should be able to see here that the 2x plus 6 is 2 times x plus 3, and we also have times x squared. So what can cancel here? We can cancel the x plus 3, and we have 1x on top, and we have x squared on the bottom, so the squared will cancel the x on top. So what we're left is just with x minus 3 on top and 2x on the bottom. So if we look at the second way of doing this, I'll just take out the denominators here. So if we can identify what we want to get rid of on the bottom, x squared is what we want to get rid of. So if I multiply everything here by x squared, I'm going to have 1 times x squared, which is x squared. Now I'll put it in like this in long form. 9, we're multiplying it by x squared. The x squares will cancel, but as higher level math students you should be able to write x squared minus 9. So that's what you'll end up with on top, which you can see is this one here. And on the bottom, if I multiply 2 by x squared, I get 2x squared. And if I multiply 6 over x by x squared, it's like this, x by x, we're just going to get 6x. So I end up with, on top, x squared minus 9, which is the difference of two squares. And on the bottom, the highest common factor between 2x squared and 6x is 2x, which would leave x plus 3. And I can cancel off my x plus 3's to be left with x minus 3 over 2x. So both methods are perfectly fine, whatever you choose to use. Sometimes this method of multiplying by something that will get rid of the denominators will actually be a better method to use. So let's have a look at a couple more examples. An example like this where we have the same denominator. Now quite simply you'll get to the point where you'll see that you can just cancel if we have the same denominators, and the reason is that we could multiply top and bottom by 1 over xy and we're not changing the value. Sorry, xy over 1, not 1 over xy, xy over 1, or just xy on top, which will cancel them off. So we're left with 2x minus 6 over x minus 3, and the top factorizes to give me 2 times x minus 3 over x minus 3. So this one we'd be left with a 2. So pause the video and test yourself with these two. Okay, so you may have identified that we have a b on the bottom here, so we multiply everything by b. So everything by b, we're going to get ab minus 1 over b minus 1, and because we've multiplied by b, there's no need to do anything else. We can see that the top and bottom can't factorize any further, so that's quite simple. You could also put a over 1 and 1 over 1 and use the method that we saw at the beginning of the video. For this one, it might be, let's get the same denominator on top, so we're going to cross multiply, and we're going to have x plus 1 times 1. We don't need the times 1, we'll put it in just to show the two denominators here. So cross multiplying 1 times x and 1 times x plus 1. And then on the bottom, we're going to have 3 over x plus 1. You can see the same denominators, so multiply top and bottom by x plus 1, and we're going to be left with 2x plus 1 over 3. So slightly different methods can be used for complex algebraic fractions. Practice these again if you didn't get them all right, and then move on to Algebra 5.